if we're trying to find a tangent line at a given point, or the slope of a line at a given point, what you usually have to do is you have to go through, pick out a point on one side, pick out a point on the other side, use the equation y2 minus y1 over x2 minus x1. That's after figuring out what your y values are there. You go through, you get your slope finally, and you have a headache because it just took forever. So let's look at another way to try to do this problem, all right? So instead of picking 2 points on either side, what if we use the original point, which was x, whatever x is, if it was 1, 2, great. Then we pick some point that's just a little bit further away. Because that's the goal, isn't it? To have it just a little bit away. So that's what we've done here. We've picked a point, it's h away from x. So it's just a little bit further along, whatever we want x to be. Okay? We can have it be almost 0, which is what we're going to actually do. We're going to use limits. So with this problem, we have y2 minus y1 over x2 minus x1. That's going to tell us our slope between these 2 points. All right? So if I take y2, let's say these are my y2, well, I'm going to have f of x plus h, that's my y value, isn't it? That's where my y is, minus f of x over, we look down here, I've got my x plus h minus x. So this would be the equation as we're trying to figure out the slope between these 2 lines. I can go through and simplify this. The top, there's not a lot I can do because x plus h isn't the same as x. However, what is x minus x? It's nothing. So this all simplifies to f of x plus h minus f of x all over h. Now, do we want h to be a really big number? Do we want it to be really far away? Or do we want it to be really close? We want it to be really, really close. In fact, we want to get as close to 0 as possible. So over here, I'm going to have this set up as a limit, and we want h to be as close to 0 as possible. However, h can't be 0. Okay? Let's look at why. Can you divide by 0? We can't. We can't divide by 0. So that is why we're saying h approaches 0. The closer we get to 0, the closer these 2 points are going to be. If you think about it, if h was 0, this would be f of x, that would be f of x, you'd have x and x. They would be the same point. They can't be the same point. However, they can be an h distance apart. H can almost be 0, but it cannot actually be 0. So let's try an example problem. Here we have the line y equals x squared. Okay, we've got our f of x and x. We have our x plus h and f of x plus h. And our difference quotient formula, where you have f of x plus h minus f of x all over h. Now remember, that's just the slope formula, y2 minus y1 over x2 minus x1. Well, if I want to know what the slope is at any given point of this curve, instead of finding 2 points, let's use this formula real quick, okay? So we're going to take our x squared, and remember, y can also be f of x. They mean the same exact thing, okay? So f of x equals x squared. So over here, we get, I'll use red, f of x is x squared, so it's going to be something squared, but instead of x being inside, I have x plus h. So I replace my x with x plus h. Here I don't replace this with anything. Minus x squared all over h, okay? Well, let's go through and do a little bit of algebra now. Remember how to square a binomial. It's the first, well, now I'll go through and do it. So here it's going to be x plus h times x plus h, because you're squaring it. First times the first, that gives me x squared. xh, xh. You can also say hx, I guess would be more appropriate. And then finally h and h would give me h squared. We go through, combine those, that gives us x squared plus 2hx plus h squared minus x squared all over h. Okay? Now we can do a little bit more algebra. If we're doing the algebra right, remember we're taking the limit of each of these. As h approaches 0. If we do this right, the only thing that should be left is anything that has an h in it. So here we have an x squared and a minus x squared. What's x squared minus x squared? It's nothing. They cancel out. Okay? That leaves me with 2hx plus h squared all over h. Okay, let me see. Can you guys still see that? I can still see it. Well, can I divide everything by h on the top? Absolutely. That leaves me with 2x plus h. Okay? You're still able to see it. Remember, that's the limit as h approaches 0. Okay, that's the limit as h approaches 0. Well, as h gets closer and closer to 0, what's our answer going to be? It's going to be 2x. Okay? So this 2x represents the slope at any given point of this curve. All right? Now, if you remember from last time, we actually did do this problem where x was 1. Okay? And this point here was 1. When the slope was 2, if I remember correctly. So our slope, m, was 2. Well, here's how we use this 2x to figure out what the slope is at any point of the curve. All we do is we take our x value, 1, and we plug it in. What's 2 times 1? It's 2. So our slope when x is 1 is going to be 2. Well, let's look a little further down. Let's say over at 2. What would our slope be at 2? Well, if you think this is actually going to curve up a little bit more, I'm sorry, I'm not the best person at drawing these. Okay, it curves up a little bit more. At 2, it looks like it's a lot steeper, so it's going to be steeper than 2. Maybe 3, 4, I don't know. Okay, well, let's do the same thing. We take 2, we plug it in. What's 2 times 2? We're going to have a slope of 4. Okay, let's try another problem. There you go, let's try another problem. So, we've got this equation here, f of x equals 2x squared minus 2. I want to know the slope at any point of this curve, okay? So what I'm going to do is I'm going to take this 2x squared minus 2 and use my limit formula, all right? So f of x minus h, wherever there's an x in this equation, I'm going to replace it with plus h, not minus h. So I take that, and it's going to give me, let's see here, 2x plus h squared minus 2 minus, let's see here, 2x squared minus 2. All right? The reason I put the parentheses here is I'm going to be distributing that negative all the way through. Same thing here, I need to square this. This is going to give me 2x squared plus 4hx plus 2h squared minus 2 minus 2x squared plus 4. Okay? All over h. Well, can I simplify anything up here? Sorry, that shouldn't have been a 4, that should have been a 2. Well, yeah, I can. I've got this negative 2 and a positive 2. Those cancel out. I've got a negative 2x squared and a positive 2x squared. Those can cancel out. All that I'm left with is this 4hx plus 2h squared over h. I'm going to write that out. 4hx plus 2h squared all over h. I want to find the limit as h approaches 0. Remember, h can't be 0 because we're dividing by h. If we can get rid of this h in the bottom, then h can be 0. But until we get rid of this h can't be 0. Well, hey, I've got two h's on top. So what we could do is we could factor that out. That gives me an h, 4x plus 2h all over h. H's cancel. You could have also just looked here to take an h out of everything. Okay, that's going to give me the limit as h approaches 0 of 4x plus 2h. Okay? Well, if h is approaching 0, what is this going to get close to? What's 2 times basically 0? It's going to be 0. It's gone. So our slope, or gradient, at any point on this line is going to be 4x. 4 times whatever x is will be our slope at any point on this line. Okay? So if I want to know what my slope is right here, where x is 0, well, what's 4 times 0? It's 0. Hey, and it's flat. So we know we got that part right. Let's say we're looking over here at -1. What is my slope at -1? Well, what's 4 times -1? It is -4. Right here, my slope is 0. Over here at 1, what's 4 times 1? It's 1. It's 4. Let's come all the way over to 2, okay? Over here at 2, it's going to be pretty dang steep at that point. So my slope at 2, well, what's 2 times 4? It's going to be 8. You notice it keeps getting steeper and steeper and steeper and steeper. All right? You come all the way over to 100, well, your slope's going to be 400 if you come all the way over. Okay, last one. Let's try f of x equals x squared plus 4x minus 4. Let's find the equation that will give us the gradient, or slope, at any point of the curve. Okay, so if I wanted to know the gradient right here, I would just plug in 1 and it would give me my gradient. Or if I wanted to know the gradient right here, same thing. Now, a way that we can check this is if we plug in -2, we should get 0. If we plug in -2, we should get 0 for this problem, all right? So, let's use our limit formula here. We've got, let's see here, x plus h squared plus 4x plus h minus 4. Okay, that's this first piece, minus f of x, which is x squared plus 4x minus 4. By the way, if you think you've got this one, go through, give it a try on your own. Divided by h. Now comes the fun algebra. We go through, we do this. That gives us x squared plus 2xh plus 4x plus 4h minus 4 minus x squared minus, remember I'm distributing that negative, 4x plus 4. All right, all over h. Pause it if you need to. Make sure I did everything right. Pretty sure I did. Now I need to look for anything that I can cancel out. For instance, this 4 and this 4. The -4x, the +4x. Anything that does not have an x should be canceled out. If it doesn't have a partner that can cancel it out, you might have done something wrong. Minus x squared, positive x squared. Cancel, cancel. This has an h, that has an h, that has an h. So far, so good. All right. Ooh, you know what? I missed that one. I should have had an h squared right here. Okay. So we drop this all down one level. That gives me 2x h plus h squared plus 4h all over h. Okay. Can I cancel an h out of everything? Yes, I can. That gives me 2x plus h plus 4. Now remember, this is a limit as h approaches 0. Since there's no h in the denominator anymore, can I just make h 0? Because this isn't 0.00000000000000001 basically just 0? It is. So as my limit as h approaches 0, this is going to end up equaling whatever 2x plus 4 is. Okay? Now remember, we're going to check this. When x is -2, f of x is -8 down here, but the slope should be 0. Our slope should be 0. So if I plug -2 into this equation, I should get 0. If I get 0, then I probably did it right. So let's give it a try. We've got 2 times -2 plus 4. What's 2 times -2? It's -4 plus 4. Oh, that gives me 0. That checks out. We can try it on another piece. Over here, we should get some negative number. Okay, let's try it. We should get some negative number. That's at -2, 3, at -4. So 2 times -4 plus 4. You guys, if you do the math, you get -4. Ooh, our slope is -4. Is it steep? Is that pretty steep and going down? Absolutely. Over here, we should get, it looks like it's the same level, but positive. So this should be +4. Let's try it. We should get +4. Okay. But it's 0, so 2 times the x value's 0 plus 4. Ooh, 2 times 0 is 0. 0 plus 4 is 4. Did we get 4? We did. Let's try these last two just to be sure. So up here, again, it should be a large positive number, our slope, because it's pretty steep. X value is 1, so I'm going to plug 1 in. See, 2 plus 4 is 6. Boop. Right here at -1, if you wanted to try it, you'd probably get 2. Okay. So look, you got 0, 2, 4, 6. See how the slope keeps going up and up and up? Okay. Well, over here, we should get -6 if we did this right. Let's just try it. M should be -6. You're probably all thinking, yeah, Harper, we know it's going to be -6. Well, what y value am I going to, sorry, what x value am I going to plug in? 1, 2, 3, 4, -5. 2 times -5 is -10, plus 4, that's -6. We did do it right. Cool. Okay, it's your turn. Give it a try. What is the slope at any point of the graph? Find the equation for it. Pause the video if you need to. It's now my turn. So we're going to use the limit equation formula. Some of you saw past this and you didn't actually need to use it. That's okay. So here we go. We've got 2 times x plus h plus 3 minus 2x plus 3 all over h. Okay. So here we go. We're going to distribute the 2. We're going to distribute the negative. That's going to give me 2x plus 2h plus 3 minus 2x minus 3 all over h. I'm going to go through, cancel stuff out. My 2x, my -2x, my -3, my +3. That leaves me with 2h over h, which simplifies to 2 with the limit as h goes to 0. Well, there's no h's left. My answer is just 2. So let's see what that looks like over here. Okay? We're saying that 2 should be the slope everywhere. Hey! Oh, ding, ding, ding! Isn't that what this formula is? The, what is it called? Gradient intercept form, point intercept form. No. Slope intercept is what it's called. Gradient intercept, slope intercept, okay? You got 2. That's your slope, always. It's a constant slope the whole way. Hey, and this formula over here told us, you know what? It's always going to be 2. Okay, if you got that, great. If not, ask me a question. Leave me a comment down below.